It's been a number of years since we've had a soybean trial. Soybeans are a long season crop, and while we've grown them successfully in the past, yields have been a little bit disappointing. However, we decided to be involved in a soybean trial this year, which is being led by the Southeast Research Farm. Historically, soybeans have been seeded on the later side to avoid cold shocking the germinating seed. However, more recent study has found calendar date may be more important in determining crop success than soil temperature. The objective of this study is to determine when newer, rapidly maturing soybean varieties should be planted in Saskatchewan. The varieties in this study certainly look very different in terms of height and leaf structure. Well, let's have a look at the results. This trial was developed and led by Anmoldeep Matharu and Lana Shah from the Southeast Research Farm. Financial support came from the Saskatchewan pulse growers. The following agri-arm sites participated in the study. However, Swift Current had to drop out due to environmental conditions. Each trial was set up as a split plot. Essentially, we compared varieties with different maturities when seeded early and later at the normally recommended time. The varieties listed here are in increasing length of maturity. Not surprisingly, the soybeans seeded early in blue took more time to mature. Soybeans are a warm season crop, so the cooler conditions experienced when seeded early slow the rate of development. Averaged across site, the early seeding was 13.4 days earlier, but this only hastened maturity by 9.8 days. For the most part, varieties with earlier maturity ratings took less time to reach maturity. However, the maturity of soybean number 3, which was NSC Dauphin, seems to be earlier maturing at all sites than what you would expect based on its maturity rating. In order to give you a visual on how much the varieties differed in maturity, I'll show you some slides taken from the Yorkton site. Nebo has the shortest maturity and PV22S002 has the longest. On the left, varieties were seeded on May 15th, and on the right they were seeded on May 27th. These pictures were all taken on September 9th, and you can see quite a difference in maturity. Fast forward 8 days later to September 17th, and you can still see quite a difference in maturity. However, we had a warm, open fall and managed to get everything harvested on October 4. I should note that in research we can harvest crops with a higher grain moisture than a farmer would usually dare, as it is easier for us to dry grain sacks that are small than it is for a farmer to dry down a whole bin. Yield-wise, Yorkton was the only site where yield was significantly reduced by early seeding, which is odd as soil temperature was still above 10 degrees Celsius when we were seeding early on May 15. I would not assume the soybeans were cold shocked based on that soil temperature. Moreover, soil moisture levels should have been better for the early seeded soybeans, if there were differences at all. So, none of this really explains why the early seeded performed poorly. Numeric trends for lower yields when seeding early were also apparent at Prince Albert and Outlook. Outlook, under irrigation, stood out as having the highest yield. However, a lot of the dry land yields were not very impressive. At Yorkton, our plots are wide and we only harvest the middle 4 rows to avoid edge effects. In other words, our plots are pretty representative of what a farmer would expect to get. Our best yield was 32 bushels per acre when seeding later, and that's not very impressive when you consider the neighboring canola trial did 50 bushels per acre. Significant yield differences were detected between varieties, but the ranking of varieties was not consistent between sites. Interactions were detected at Redvers and Outlook, but there wasn't anything of real agronomic significance to report. There are no stats applied here, but when you average sites all together, there really isn't a strong trend that earlier or later maturing varieties are better yielding under our environmental conditions. The end user wants high protein soybeans. There's a declining protein gradient towards north central and northwestern North America. North America has experienced a decline in protein levels that is likely related to breeding for higher yield, but there's clearly an environmental effect that may also be related to breeding for shorter season varieties. The protein basis for commodity soybean export to China is currently at 39% on a dry weight basis. Food type soybeans must meet an export basis of 48% on a dry weight basis. You can see by our protein levels that we're really not making the grade. While they can blend our soybeans with higher protein lots, this creates a market risk still for us here in the northern areas. As varieties are bred for higher yields, it becomes increasingly difficult to maintain high protein. Early seeding date was hoped to increase grain protein by providing more time for protein formation. However, Dr. Lawley at the U of M found plant dates from April 27th to June 16th did not influence protein yields. Prince Albert was the only location in our study where seeding date had a significant effect on grain protein, and in this case, early seeding reduced grain protein. Significant protein differences were detected between varieties at all locations. The earliest maturity soybean, variety Soy 1, which is BY Nebo, had significantly lower protein at all the sites except Scott. Interactions were detected at Prince Albert, Yorkton, and Outlook, but I won't be covering them as they are of little agronomic significance. Conclusions. There are soybean varieties available that can mature in our climate, but the yields in our study varied from 18 bushels all the way up to 80 bushels per acre on irrigation. At Yorkton, the late seeding gave our best yield at 32 bushels per acre. Seeding 13.4 days earlier than normal hastened soybean maturity by 9.8 days, but at Yorkton it also resulted in reducing yield to 22 bushels per acre. There were a couple of sites that followed this trend, but the rest did not. Protein levels for our soybeans are low, and BY Nebo had the lowest. Yield rankings for varieties was not consistent between our sites. Again, I'd like to thank SURF for developing this project and the Saskatchewan Pulse Growers for funding it.